Hi, my name is Nurul Husna Betty Samsudin, student ID MH19020. Today we will present about the project proposal for our group, which is Group 2. This is our group member. First is Ali Fakhrul Razi, second Muhammad Amrul Hafiz, third Harith Iqmal, fourth Muhammad Naim, and fifth is me. So I will present about introduction. CFD is a part of CAE that permits the numerical simulation of fluid motion. This is commonly used in motorsport aerodynamics to improve the design before doing physical tests on product prototypes. CFD is now widely used technology for producing solutions for fluid flows, either with or without solid contact. And it will explain about the physical characteristics such as velocity, pressure, temperature, density, and viscosity. For our project background, vehicle design is crucial aspect for product prototype engines, and engineers must be optimize their design and do physical tests on it in order to meet all the objectives. Analysis and mathematical models vary depending on the nature of the problem that may arise. This might lead to the development of precise scenario or issue solutions. So we have three objectives here. First is construct drawings using SolidWorks and CFD analysis using the design of Ahmed body. Second is compare the design with the selected car model and their characteristics and plots. And the third is analyze the region for the car flow. So I will give to the second.
Assalamualaikum and hi. My name is Muhammad Rafiz bin Kamal Azmi and my ID is MH19013 and I will present about the problem statement. First problem statement is what is the objective of the CFD analysis to be performed. Okay, first we need to know the computation of integral quantity, for example lift, drag and yield. Secondly is snapshot of field data of velocity consideration. Thirdly is the shape of optimization aimed at improved performance. Okay, second problem statement is what is the type of the flow. Firstly, the lamina, secondly, is turbulent, and lastly, it is steady or unsteady. Okay. Okay, that's all for the problem statement. Then, next, I will go to the methodology. Okay, for the methodology, the study of computational fluid dynamics is concerned with the numerical solution of mathematical model of physical process involving fluid flow. An inspection of the flow of fluid in relation to its physical property, including velocity, pressure, temperature, density, and viscosity, is carried out during a CFD software study. CFD analysis is basically consists of the following three phases. Firstly, the pre-processing. Okay, this phase is the kind of flow that need to be modeled. You need to know with the viscous or viscid flow, compressible and incompressible flow, and steady or unsteady flow. Several assumptions are made. Okay, second phase is the solving. The solution is the component that is responsible for performing the actual computation, and during the solving phase, okay, processing capacity is required. Lastly is the post-processing. At this point, the analysis has ability to verify the result, and based on the result, the actual inference can be reached. That's all from me. Thank you.
Before we proceed with the CFD analysis, first we have to do the design of our selected vehicle, which is the Pro Diva. Okay, so the thing that we have to do is we have to create a 3D model that is similar, resembles to the Pro Diva based on its dimension. As we can see here, the length is 3,995 millimeter, although some sources says that the length is around 4,000 millimeters, and the wheelbase is 2,525 millimeters. The width of the vehicle is 1,995 millimeters. Meanwhile, the height of the vehicle is 106,020 millimeters. So these are all the measurements that will be taken into the creation of the 3D model. Okay, so based on our skill set, the first model that we've done is quietly boxy. The rough edges, as can be seen over there, shows that the aerodynamic will be less efficient. And the second model is the improved version of the first model, as you can see here. The model has slightly refined lines. The edges have been filled and slightly chamfered based on the dimensions of the Ativa. And for us to do the CFD analysis, this is the Ahmed body design, which is based on the Prodo Ativa. The dimensions are same as the one that I've stated before, and the fillet angle, the fillet radius, is 300 millimeters on the back, and the chamfer angle, which is the front windshield of the vehicle, is 35 angle degrees. So then after that, we can do the CFD analysis. Thank you.
My name is Muhammad Haris Iqbal and I will continue to present the flow analysis. Okay, by using flow simulation that add-ins in SolidWorks software, we can proceed with the CFD analysis using the Ahmed bodies. So, as we can see, this is the surface plot of the Ahmed bodies car. Then this is the isoline and contour data. And last one, this is the flow trajectories for the Ahmed bodies car. So we set the air velocity, initial velocity, which is 30 km per hour. And from the figures, we can observe that the highest pressure is at 101 kilopascal, and the lowest pressure at the back of the model, you can see it is 100 kilopascal. That's all from me. Thank you.
Okay, for my part, I will explain about the discussion. Centerline pressure distribution and the total aerodynamic force are the only variable used in many studies to compare the CFD prediction with the experiment. There is reason to believe that the agreement between the predicted and the measured force may be coincidental unless a field method prediction exhibits the same flow phenomena in the entire flow field, with the consequence that the predicted pressure distribution on the complete surface match that of a carefully conducted experiment. The air pressure over the various surfaces of the model geometry is given to us by the pressure distribution. Regions of high, medium, and low pressure are shown, respectively, by the red, yellow, and the green patch. As it hit the car, the air virtually stopped moving completely, which caused it to put a tremendous amount of the pressure on the front engine grill, which is depicted by the red area. The upper and the lower surface of the vehicle are then given a separate airflow. As the air passes over the Ahmed body curve NASA surface, with the higher pressure, it moves faster and the pressure decreases. After completing its design, development, and subsequent analysis, CFD findings for the various types of the modification to the Ahmed body with a 10-degree rear slant angle are provided. The majority of the plot show a light greenish blue color zone, defining that the majority of the model body is being applied pressure at the range of 100 kilopascal to 101 kilopascal. By means of the feed flow, the front portion of the Ahmed body apply the most pressure. Yellow with the reddish and green undertone serve as a signal for this. The rest of the body part experience reduced pressure and the smoother flow of the fluid after the fluid reach the front portion of the model. A vehicle should ideally have this Ahmed body shape. Okay, next we go for the conclusion. The Ahmed body is a useful tool for the simulating the key aspect of the flow over a car. The body data has enough quality to be taken seriously as a legitimate geometric model for this flow. Strong agreement between the simulation and the empirical result can be shown for the fine-tuned mesh, and the results are within the 5% uncertainty range. The flow parameter and the numerous aerodynamic phenomena of the flow over the Ahmed body are well simulated by the model. Thank you.